OCR bot. Good. So what is an OCR bot? What is the difference between OCR and IDP? QR reader is not an OCR. Reading food menus, nutritional labels, object recognition, all of these are not OCR. Google Lens is a good example of OCR. Barcode reader is not the job of an OCR. Image to text is a good definition of OCR. Okay, good. So we all know what is an OCR. Chalo, good. Now, what is the difference between OCR and IDP? What is the full form of IDP? Any guesses? It's in the title. Intelligent document processing, right? So what is the difference between OCR and IDP? Scanning? No. IDP takes an action, not really. Human written text? No, that's ICR. So just a FYI, OCR and ICR are two different things. ICR is intelligent character recognition and OCR is optical character recognition. When we talk about OCR, it's generally mapped to printed characters. And when we say ICR, it's generally mapped to handwritten text. Okay. But what is then IDP? Reading characters from images is, is OCR. IDP processes the doc, more of an advanced to automate workflows. That's a very good definition. Uh, it's uh, it's a good definition, but not the one that I was looking for. It's not incorrect, it's correct, but not the one I was looking for. OCR can only read characters. IDP is OCR with AI machine learning. Harinder, that's again a good definition, but not the one that I was looking for. Okay, so let me rephrase the question. IDP is a wrapper on top of OCR with AI. Again, a very good definition, but not the one I was looking for. Yes, good. Saurabh has given us the correct information and Vivek as well. So OCR extracts text, whereas IDP understands the text and extracts information. Okay. So if I had to literally, uh, simplify it in simple terms, OCR is text extraction and IDP is information extraction. Okay. Now, what is the difference between text extraction and information extraction? For example, let's say you have a resume, right? OCR will extract all the text from the resume. But if you have to identify what are the entities in the resume, what is the name, what is the skill, what is the certificates, what are the projects, then that's information extraction that comes under IDP. Google Lens has both capabilities. I don't know that. It may be true. I am not aware. Summary feature of Gmail is IDP. No, that's not there's no document in Gmail, right? Maybe if there is an attachment and then Gmail summarizes that attachment, then yes, that would be IDP. Just summarization of the email text is not IDP. Okay. Good evening. Okay. So this is the difference between IDP and OCR. So I hope you guys don't mind. I'm going to jump straight into it. And let's start. Okay. So, like Vivek said, I think it was Vivek. No, this is not about RAG today, Adiba. I think it was Vivek, right? Yeah, it was Vivek who said that OCR only digitizes text, but IDP comprehends the context structure of the information within documents. And yeah, okay. So IDP is designed to tackle the challenge of processing unstructured data and structured data, or not structured data, basically semi-structured data. What is the difference between unstructured and structured data? Then we'll talk about semi-structured data. So can you guys give me an example of a structured data? SQL database, yes. uh, iris data set, yes. Yes. Data what we can read and pass as pandas data frame, that's a very good definition, that's a very good information. XML is not unstructured, it is still structured. Okay, so XML, JSON, CSV, Excel, data frame, SQL, all of these are structured data. They follow a certain schema, they follow a certain pattern. Now that schema can be changed, but once that schema has been designed and fixed, it new data that comes in has to follow that schema. This is not true for unstructured data. Unstructured data may be documents, images, audio, video, even for some cases, even uh, things like MongoDB items. These are called items. NoSQL database items can also be called as unstructured because they don't have to follow a particular schema, right? Okay. JSON is not unstructured, buddy. JSON is structured. My WhatsApp chats are unstructured data. Yes, your WhatsApp chats are unstructured data. Okay. 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 Collection is there, but within collections, there are items, right? Documents. Documents is the term used by MongoDB, but for everything else, generally it's, items. Excuse me. Social media is, yes, again, unstructured data. But then the question becomes, what is semi-structured data? We understand unstructured data, we understand structured data. What is semi-structured? Yes, partially structured, but can you give an example? XML is not semi-structured, it is structured. Phone book is a good example of semi-structured data. So think about all of these unstructured data types that we talked about. Documents, text, and again, WhatsApp chats are also text. Social media feed is also text, right? Some of these, even though they are unstructured, they will follow some pattern. Let's take the example of uh, uh, a bill that you get at a hotel. Each bill will have their own template, right? The organization will be different, but for each template, but all of those templates will contain the same information. Each bill has to have the item that you bought. Each bill has to have the quantity, the rate, the value, the taxes, who served you, what is the name of the place, what is your name, things like that. Each bill will have that. This may not be in the same format for every bill, but every bill will have this information, right? So kind of data sets are called semi-structured. CSV is not semi-structured. Again, CSV is structured. Okay. Once you decide and fix the columns of a CSV file or an Excel file, uh, it forms a structured data set. Okay. JSON is not unstructured. JSON is structured. Okay. Log files, yes, they can be unstructured, semi-structured actually, not even unstructured. Okay. Each JSON output can also be different, can be different in different JSON structure. Why is it structured? But again, remember that it can, so once you decide a JSON schema, right? Once you decide that this is the information that you will have, will you change it? Can it be changed? If you change it, won't you be breaking the API contract? So this is structured data. Once we decide the bill format, it won't be changed as well. But there is no way to basically ensure that each and every information is filled, right? Sir, I live in New Zealand and classes are at 2:30 am, therefore I am falling behind. Am I able to get grace, extra grace time a part of the part that would be very, very difficult to arrange for one person? I believe that, you know, you will still get the recordings and everything. But again, the point is that it will be very difficult to change the rules or bend the rules for a few folks. Okay. Okay. So what is the process flow of an intelligent document processing system? We understand what an IDP is. In fact, let me just show you the input and output that we are going to work with today. So let's just look at the input first. So this is a bill, right? So this is definitely not in English, but that should not matter because each bill will have a quantity, a code, a price, a discount, an amount, and what is the total, the tax, the rounded total, right? And so on and so forth. Okay. So this is the input. What is the output that we are trying to get? It looks something like this. Oi, oi, oi. Sorry. Yeah, it looks something like this. Company. So what is the company name? The input image and the output that I have picked up are not the same, so don't worry about that. What is the date of the bill? What is the address and what is the total? That's it. These are the four fields that we are focusing on right now. Everybody understood this much, right? What is our input going to be and what is our output going to be? No. So our input is going to be this image, which contains a basically a receipt. Somebody must have eaten something somewhere and they have basically they have received a bill, right? And our output is going to look like this. What is the company name or the hotel name or the restaurant name or whatever, the date, the address, and the total amount paid. Everybody understood this much? Yes? Yes? No? Just one person got it? Okay. So we'll talk about how to reach there throughout this session today. But first, I wanted to talk about, just like yesterday, I wanted to talk about what is the standard process flow of any IDP system, right? Of any intelligent document processing system. Okay. So the first thing that many people forget is document ingestion. This is literally one of the hardest steps because documents have to be imported not just from one source, and it has to be programmatic, right? You have to literally write code that consumes a document that is somewhere in the business system, and there can be many sources, multiple formats of the documents, and yeah, that's really hard to tackle because there's no AI that tackles this. Literally, if you don't send Google Gemini a PNG or a JPEG image, it will reject your input. Okay. So you have to convert those into images. All of that will be handled in this particular step. Okay. Right. Then what do you need to do? For each document, you have to improve the quality of the document. We all know that scanning a document is not a perfect exercise. There can be bends, creases, bad scans, anything and everything that can go wrong will go wrong in this particular scanning exercise, right? So you have to basically design a pre-processing stage that improves the quality of the document, improves the quality of the image. Okay, this, and we'll see a lot of these things, including reduction of noise and skew correction and binarization. All of this we'll look at today. But yeah, improving the quality of the document using simple OpenCV methods. Okay, you should not be using AI at every step because that is very time consuming. You should not be using AI at this step because it is going to be very time consuming, right? Then, for example, if you have multiple kinds of documents, for example, in India, you have your Aadhaar card, PAN card, passport, driving license, voter ID. All of these can be there. So you have to have separate models for each of these document classes, right? You have to have separate prompts for each of these document classes. But how do you identify which class is which? Well, you have to perform some sort of document classification. Okay, is that understood? Uh, there's a lot of chatter around the submission dates and everything, but let's not talk about it today. But I just want to know everybody understood. Can you repeat again? Okay. So what generally happens is when you're building an intelligent document processing system, there are two ways to go about it. You either create a very generalized system which works on all documents, but you cannot be sure of its accuracy. Or you create a a specialized system which works for each document class separately. So you will have one model for Aadhaar card, let's say, one model for PAN card, one model for passport, one model for voter ID, one model for driving license, right? So you can use separate models, but then again, to do the data extraction or the information extraction, you will need to do something called as document classification beforehand. You will need to identify which document class this image or document contains, and then basically have to process that particular model. Okay. For scanning? No, no, not for scanning. Scanning has happened over before this. Model means IP algo. I don't know what that means, Praram. Image processing algo, yes. Oh, IP is that's never, I've never seen IP and image processing. But yeah, document classification, you will have to build a image processing algorithm. It may be a deep learning or a machine learning or even a Gen AI model, depending on the resources and the time that you may have. Okay. Now, this is where you do all these things, your text extraction, your information extraction. This step is called data extraction. It's simply called data extraction. Okay, for from an invoice, you can pull out the invoice number, date, vendor name, and even line item details. Each and every line item can be extracted as well. Okay. Okay. Do we have to produce JSON file as an output? Yes, you have to produce. So this is a very good question. What do you guys think? Why do we need to produce JSON file as an output? The answer is yes, you have to produce, not because it's structured. Can be understand by front end and back end both. Can you use, I think you are on the right track, but can you use better language, Shiva? Easy to communicate and parse the output? No. Helps in API, connects with API. Absolutely correct. Right? So remember, whenever you're building, so we have talked about a lot of machine learning and data science and deep learning and Gen AI models, right? Now, whenever you're building any machine learning model, you'll have to convert it into an API. At the end of the day, this machine learning model is not going to sit in your laptop, right? It has to be productionized. And to productionize the machine learning model, you will have to convert, you will have to wrap an API on top of the machine learning model, right? And this is where things like fast API, Docker, CI/CD pipelines come into play. But yeah, this is what you will need to do. So it should be very it is very ideal if your output is already JSON, and if you don't know, APIs work with JSONs only. So if your output is already JSON, you don't have to take that very small step of converting it into JSON. So this is why we need to have JSON as an output. Okay. Okay. I'm sorry, sir, but yesterday's submission, we can use the same prompt and just, tune it according to a DB, right? Yes. Okay. Right now, many tools use JSON and Markdown files as output, but which one should you use, or which one is best suited for which context? So, uh, again, when you say tools, you're probably talking about LLM tools, Mario. I hope that's what you're talking about. The best language you can converse with an LLM is Markdown. Almost all LLMs understand Markdown the best, then XML, then JSON, then HTML, and then plain English. So that if you remember a unified prompt framework, we were passing everything as Markdown only, right? So it is very, very helpful if you learn Markdown. Okay. 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 Once you have extracted all information, you can basically apply some rules to validate the data. For example, let's take the example of total, right? If you remember, total doesn't can total have like characters, or it should be just digits? Both maybe. If I think about removing the currency aspect, the currency symbols, should the total be only digits, or it can have characters as well? And obviously, decimal digits are okay. So it should be digits, right? And we can add as a simple rule in Python that does the total contain uh, characters or only digits? Yes, we can use regex, we can use anything, but it will be simple base Python, right? We need to validate our information that has been extracted. Ideally, it should be simple regex, simple Python, because again, we do not want to spend too much time in this step because our overall response will be slowed down as well. Only these two steps should have some sort of machine learning, deep learning, Gen AI, because otherwise, if you keep every process, if every step has some sort of Gen AI, some sort of deep learning, some sort of machine learning, then every process will take much more time. Plain basic Python is faster than any machine learning model. It is faster than deep learning models, and it is definitely faster than Gen AI models. I hope everybody is, there's no doubt about this particular point, right? Yeah, so currency can be of any currency, country. But again, I have explicitly stated, right, that the currency symbol, we can ignore the currency symbol for now. So then the total will only be digits, right? Okay. So this is what data validation step is. Okay. Then finally, you have to do all of the integration that I was talking about. Convert your entire model or module into an API, Dockerize it, deploy it. That pushes the data, the extracted data or the extracted information into a downstream database. Okay. So this is what integration step is. So these are the six major steps of any IDP solution. Okay. You may have some variations, but these six steps will be followed no matter what kind of IDP system you are building. Is that understood? I lost the session completely. Why? Do you guys have any difficulty in understanding what I'm talking about? Okay. I hope Shivang that you will get it as we progress ahead. Okay. So again, remember that these six steps they will stay constant. The underlying algorithm, underlying code that you may want to use for, let's say, pre-processing or data extraction may change from system to system, from use case to use case, but the steps will remain no matter what kind of IDP solution you are building. Okay? Okay. So what is our approach going to be? Saurabh Shastri, if some invoices are in PDF format, some in JPEG, will it be handled in pre-processing on or in classification? So it will be handled in the document ingestion step itself. You have to convert everything into images. Your OCR or your even your IDP does not work on PDFs. It will only work on images. If you have Word files, then you have to first convert them into PDFs and then to images, right? So things like that. You have to convert everything into an image before you can pass it through the system. Okay. Can anyone summarize that? So maybe somebody else can do that, but it's okay. If you haven't been able to understand what I have talked about till yet, Shivang, let's just go through our approach that we are going to use that. Okay. Okay. So what is our approach going to be? Well, we'll have some documents, PDF documents. We're going to convert them into images. Okay. How are we going to convert them into images? Document ingestion part, yes, but there are many libraries in Python that convert PDF into multiple images. Okay. So we'll be using one of those library. The library that we are going to work with today is called Pillow, Pillo. Okay. Again, there are many PDFI is another place, and yes, there are many websites that I'll use this. But yeah, Pillow is a very popular library. It's basically a library written in C++, and there are Python wrappers available. Okay. Then we will, for each page, we'll process the image to improve the quality of the image. What does that mean? So we will be improving the quality of the image. And then we'll send this, not deep learning model, we'll be using something called as OpenCV or Open Computer Vision. Okay. And we'll use grayscale conversion, noise, blur, reduction, binarization, and skew correction. It's perfectly fine if you don't understand these right now. I'll explain as we move ahead. Okay. So we'll improve the quality of these images. Now this processed image we'll have to first extract the text, not just the text. Okay. We are not extracting information. We are extracting just the text by passing it through a text extraction engine. And I'll show you guys that there are multiple text extraction engines. So you don't have to build your own, right? And then we'll pass both the processed image as well as the extracted text to an LLM engine, just how we used the LLM engine of Google Gemini yesterday. We'll be using the same LLM engine and we'll ask it to translate our output into a JSON format. Yes, we'll be using Tesseract. Okay. So I hope everybody got this approach. Any doubt? Any issues? Everybody got this? Is this document to image conversion 100% efficient? Are we lose certain no information will be lost in the process? So Jayesh, it depends on the parameters you push. So there will be no, like there will be all the pixels will remain. But for example, if you want to store images as very small images, you can do that, but then the document or the image may be slightly blurred, right? But if you store it at 100%, at zero compression, then then there is obviously the quality is maintained. If you store it as a JPEG, if you convert your document PDF document to JPEG, which has some native compression algorithms, then some quality is downgraded. But if you store it as a BMP or PNG file, then no loss of quality is there, is seen. Okay. Okay. In some smartphones where if custom fonts are installed, there is high chance that OCR can misunderstand one as capital I. How will IDP solve this? We will be using something called as data validation. Okay. I want you to repeat once the flow, please. Okay. So we'll have our input PDF document. We can convert it into multiple pages of multiple images. Each PDF document will lead to multiple images, right? Then we'll send it to an image processing module, which improves the quality of the image. Okay. Then the improved quality image is sent to a text extraction engine that extracts the text. Both the processed image and the extracted text are sent to an LLM engine. We will be using Google Gemini just how we used yesterday, and we'll be using some sort of prompt engineering, and we'll ask Gemini to extract the information from the image using the support of the extracted text to generate the information and as a JSON output. Okay, everybody understood this? Yes, no? Okay. So let's just look at the data set first before we move ahead. So there is this really popular data set called SROIEV version 2. I forget what's the full form of this. It's a really complex full form. But basically, in my head, it's the receipts data set. Okay. And if you remember the image that we showed, it was basically uh, it was basically the receipts. Why do we need image when text is extracted separately by OCR engine? So, okay, that's a good question. That's two good questions. The same question, Shruti and Praram. Can you guys give me a minute? Yeah. So if you guys remember, I showcased a an an image of a receipt, right? This is not just one image that we are going to work on. We have an entire data set that we are going to work on. Okay. Now, why do we need to send the image when we are sending the extracted text? Would anybody like to venture an educated guess? Validation, maybe. Maybe phrase it better. Yes, Jayesh. Text extraction is not absolute. They're wonderfully put. The has put the best answer. Text extraction is not absolute. So, how many of you are absolutely sure that my text extraction engine will be 100% accurate? Yes, the one to L or capital I problem. I hope everybody has used ChatGPT, Gemini, things like that, and they have seen that these models can also work with with images as well, right? I hope everybody knows that. So they have inbuilt image understanding capabilities as well. The extracted text, instead of being the main protagonist, it's literally nowadays it's a supporting role. It plays a supporting role. It's the processed image that is the protagonist now. The LLM engine will use the processed image will use it much more than than using the extracted text. Does that make sense? Mario has put it again very elegantly. I imagine the idea is that LLM understands the context and fills in any gaps that were missed in the extraction. That's beautifully put. Today, you guys are in form. Okay. Will it conflict with information, like which info should be prioritized, image or text? This is where you bring in human in the loop. And this is not in today's scope of work. But yes, there will be some conflicts as well, right? And sometimes the LLM will be wrong, but the extracted text was right. But that sometimes will be much less than the extracted text being right and the LLM being wrong. So you can have two situations, right? Uh, Actually you can have three situations. No, now that I think about it, you can have four situations. The first situation is both the extracted text and the LLM are correct. Perfect. Nothing to worry about. The second situation is the extracted text is wrong, but the LLM corrects the extracted text. This happens much more, right? So like 80% of the times you will have situation one where both the items are correct. About 15% of the times you will have a situation where the extracted text is wrong and the LLM corrects it. About 2 to 3% of the times the extracted text will be correct, but the LLM makes an inaccuracy. It makes a mistake and it moves ahead with that mistake. Okay. The fourth situation is both the extracted text and the LLM are wrong. That happens, again 1 to 3%, anywhere between 1 to 3%. And this is where you will face a challenge. This is where you will have to have a human in the loop. Okay. Can't we just give it to the LLM to extract the text? Well, no. It should not be that way, Pratham. That's a very good question, because then you will have something called as hallucination happening. Using the extracted text, you can control hallucination a lot. Okay. How can we know which is correct or wrong? We cannot know. This is where a human in the loop step has to be there. Yes, it's like a confusion matrix. Could you repeat five in Shivang, boss, what's wrong with your, either something's wrong with your internet. Everybody understood why we needed both the image and the text, right? Hallucination is when the uh, LLM responds incorrectly, but very confidently. It happens now that there are many people who say the incorrect thing with absolute confidence, and you yourself are put into doubt. That is what LLMs do. Okay. So everybody understood. Yes, that will happen, Shruti. In case LLMs, when LLM is wrong and text extraction is correct, won't the LLM overpower even with the wrong results? Yes, that was the third situation, Shruti. Okay. No, Shivang, I'll explain again. You don't need to watch the recordings. I'll explain again. Uh, so we can never be sure that our text extraction is going to be completely correct, right? To support LLM with a much better data, right? We pass both the extracted text as well as the image. The LLM tries to understand the image as well as the extracted text together. Rather than understanding them individually, it tries to understand them together and tries to understand where the text is wrong and tries to correct it. This happens at least 10 to 15% of the times, in my personal opinion, in my personal experience. There is a small scenario where the text extraction is correct, maybe 2 to 4, 3% maybe, and the LLM gets it wrong. Okay, Shivang, I hope I explained it. What do we do in our resumes? What? But if in all cases the results of the LLMs are prioritized, then why we need text extraction? It's not even being considered. It is being considered, Shruti. It's being considered quite heavily. Okay. So it's if you just pass the image, the accuracy will be much lower overall. Okay, please. And this is a very good question. You have a very interesting doubt. The obvious way to solve it is to experiment. What we'll do is we'll showcase the code of this, right? And basically you can experiment at a later stage to of just pass the image and see what is the overall accuracy. Okay. Okay. So I hope everybody understood the approach that we are going to take. So few people are saying yes. I hope there is. Okay. Okay. Good. Okay. So let's just very quickly talk about the data set. I understand that this is not that critical, but I believe that you guys should understand the data set, because in data science, data comes before the science part. Okay. So I am using this SROI data set. It's the receipts data set. And if you can download it from Kaggle using this. Once you download it, it will give you a path, right? And you can look at the path where the data set is downloaded. Okay. Okay. Now, uh, you can basically list down all of the image names. You want to check how many images there are. There are, many more things as well. So there's a train set and a test data set. Okay, so you can literally do test as well, and you will have entities, box, and image. I'll explain what box, entities, and image are in a bit, but if you just go through the image section, and again you will see lot of JPG images. I was hoping for a PDF image as well, a PDF document as well, but it seems to be not available. Okay, so let's just understand the data. Obviously, this contains the train and the test. Why do we need two data sets, train and test? Nobody is going to answer that. For testing, yes. Accuracy, yes, good. So we need to train our model on this, right? And we need to evaluate our model on this, on test data set. Okay? Okay. Now, each of these folders, train and test, we saw there are two folders, train and test, right? Each of them will contain, we saw that there were three folders in each of them. One is IMG. This basically contains the images of the receipts. The second one is box. This contains basically the text information. We are not going to use this. Okay. This is the output of the text extraction. We are not going to use this because in the real world, you will rarely get this information along with the input image, right? So are we going to perform cross validation? No, not today, Anjali. Okay. So this is basically the output of the text extraction. So this is basically this. Okay. Then again, another text file which contains all of the entities that I showed you guys. The company, the date, the address, and the total, right? Obviously, these are strings, but again, the date must be in date format, the total must be integer, the company name and address can be anything, right? So let's just look at one. So for example, this is what it looks like. Okay. So yeah, this is the entirety of the data set. Simple to understand. Anybody, any doubts over here? Okay. So we'll be, like I said, we'll be doing our image processing using something called as OpenCV. This is again a really, really complex and really large library. But For speed purposes, it is built in in C++, and it has a Python wrapper as well. And we are going to just add a few libraries for showing the images. Okay. So to experiment, we are going to just pick one particular image. We are picking this image. Okay. I hope that's all right. Okay. Then I'm just going to create a function that displays the image on as a matplotlib chart, and you can do that fairly easily. It's literally just these lines of code. And why you can showcase why can I plot an image? No, but why can I plot a JPG file? If you see, I'm not like literally plotting any JPG file, uh, JPG file, using some sort of show image tool. I'm plotting it using matplotlib. How can I plot an image? With him show. Chalo, good. Yes, so it is a two-dimensional matrix. And what does so every digital image, no matter what you take, is a matrix. Okay, it is uh, just many numbers of 0 to 255, for one for red, one for green, one for blue, and then some opacity based numbers, right? And what I am show or I am show does is converts that that the metrics into an image so that we can look at it. Okay. Okay, so this is the original image. We just created the path over here. Remember, the path of the data is, we get it from here. And I'm just doing os.path.join to get one particular image. To be honest, I picked one randomly. Okay. It didn't have any, specific reason for this. Okay. Now let's look at what image pre-processing we will be doing. Okay. The first thing that we'll be doing is we are going to remove color from this image. So let me just do this. We're going to remove color from this image. And how are we going to do that? Well, we are going to use a function called cv2.convertColor, CVT color. We're going to pass the image and we are going to say color to gray. So color BGR to gray. So BGR and RGB is the same thing, but yeah, to gray. Okay. Well, why do we need to remove color? Well, color does not add any value. It does not matter if this particular section of blue ink is blue or black. It is going to tell me the same exact amount of information, right? But if I keep color, maybe the text extraction engine will face some difficulties, right? So I will just convert these into black and white. This entire process is called grayscale conversion. Okay, so everybody understood that? Everybody sees that this becomes black instead of blue. Okay. The second thing that I'm going to do is blur reduction. Do I need to explain why having some blur is bad? Blur is also called noise, yes. But yeah, do I need to explain why having blur in your image is bad? Okay, chalo. Good. So the absolute amazing thing about OpenCV is that it gives us a, you know, a single function called Gaussian blur that reduces the blur in the image by a minute amount, not by a huge amount, because you don't want to change the nature of the image too much or content of the image too much. But yes, this is what Gaussian blur does, and there is a lot of maths underneath it. You don't need to learn this particular maths. It's perfectly fine if you don't understand this, but what you should be aware of is that there is a function called Gaussian blur that reduces the blur in any given image. Okay. Sobel is for edge detection and not for blur reduction. Is there only one function? No, there are like there must be a few dozen at least, but Gaussian blur is the best performing and the most common as well. Sobel is for edge detection. Okay. Sobel filters will not work well on a text-based image. Okay. Uh, yeah. So again, just a very small function takes in the input image, sends out the blur reduced image. And using the display image function, I'm just printing the image out. It does not seem to have a major impact, which is perfectly fine to be honest. Maybe for this particular image, it did not have an impact, but then in when you are actually working for a production level project, you will be evaluating multiple images and not just one, right? Yeah, it's kind of the same. Maybe some other, if I change the parameters, instead of 5 by 5 kernel, I do by 8 by 8 kernel, maybe that will change the the reduce the image. But definitely we will have to experiment with these parameters much more. Okay. I'm not so worried because the next step helps me a lot. Okay. So the next step, I'll show the output first, and it literally inverses the colors. And it depends on the OCR engine or the text extraction that you are using. But for example, we are going to use something called as tesseract. Okay. Tesseract basically, uh, I remember in the early days I was a contributor to this engine as well. But yeah, in way back in 2014. But yeah, Tesseract, uh, it works better when the text is white and the background is black. Okay. There are some other open source tools as well that don't have this, that don't work this way. For example, Paddle OCR or Easy OCR work better when there is a white background and black text. Okay. And this, so it depends on the text extraction engine that you choose. Okay. So again, this process is called image binarization. And CV2 again gives a really simple function called adaptive threshold to change the basically the image into black and from black and white to white and black. Is that understood? And I urge you guys to understand each of these parameters. If this is not a CV2 course or a CV2 class, if I had to, if I try to explain each of these, this will be a much longer class, right? We are already 1 hour into the class. But yeah, a simple Google search will help you with this. Okay. 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 Binarization is inversion of inversion of the colors from black and white to white and black. So everybody understood binarization? Yes, no? Everybody understood that since we are using Tesseract, we are going to do this. If we were using some other text extraction engine, we would not have been taking this step. Everybody understood that as well? Okay. Sir, is it from grayscale to black and white? No, grayscale is just the process of converting a color image to black and white. What we are doing over here is just inversing the colors, black and white ki jagah, you can say white and black. Okay. What is Tesseract? I will explain Tesseract in a bit. Okay. Okay. Then something called skew correction. What is skew? Spike. FIFO principle. Tilted. Yes, tilted, please. Positive or negative? Okay. Oh, okay. You're talking about probability distributions. No, that not that kind of a skew. Okay. Yeah. Uh, so ideally, our image should be perfectly vertical and our text should be perfectly horizontal, right? So the image over here is perfectly vertical, but I would say that the text is not perfectly horizontal. It is slightly tilted. Yes. And this happens when you're scanning or taking a photo of alignment is a good word. Yeah. This happens when with a lot of scanned and photo with your phone images, right? And what you can do is basically you can correct the skew of the image itself. You can correct the skew of the text itself, right? And there is a function that I copy pasted from Stack Overflow. It's a very old function, but it works. And I'll showcase that. Yeah. So basically, up till here, sorry, up till here, it identifies the orientation of the image. It identifies the alignment of the image. And from here to here, it rotates the image in accordance with the angle of skew. Okay. Yes, Anjali, it can be vice versa as well. The skewed and unskewed image should be printed side by side. Yes, Shivang, that's actually a good idea. We'll I'll update the notebook for that. But in any case, the orientation detection for this particular image was 0 degrees, so it doesn't really matter because there's no deskew happening. Okay. Okay. So again, this is some function that you can literally not understand, right? Just remember that such a function exists and you will find this on Stack Overflow. I'll literally add a link to the answer that I copy pasted this from, and it works. It's really amazing, right? I was using it way back in 2018 and I would still use it now. Okay. Okay. So what should I do next? Well, I should be taking an input image. So we did an experiment with one image. Now I'm going to create one function that takes this image and takes does all of the things. It converts it to grayscale, black and white. It reduces noise. It in binarizes the image. It corrects the orientation and then returns the corrected image. Okay. Everybody understood this? It's okay if you don't understand how did we correct the skew. It's okay if you don't understand how did we binarize the image. But what is not okay for you to not understand? Why did we binarize the image? Why did we deskew the image? If you understand why we had to deskew the image, good. If you understand why did we have to binarize the image, invert the colors basically, good. If you understand why we had to reduce the blur, good. If you understand why we have to, the focus right now is on the why and not the how right now, Shambhavi. Yeah, I hope I said that correctly. Yeah. So, the basically learning Open CV is not should not be the focus of this class, or in fact for you, to be honest, because there's no value add. You can just Google things, right? And nobody is going to ask you Open CV in interview, right? DSQ, please summarize. What do I summarize in DSQ? So there is this, uh, um, the there is this function in OpenCV called find non-zero. So it basically identifies all of the non-text data, white pixels in the original image, right? Okay, all of the basically the white pixels in the original image, these are black. Okay. And then it identifies what is the area, the coordinates, the angle, the rotation, angle of rotation, the width and the height of all the non-zero or white pixels. And from there, you literally just calculate what is the angle of the text as a whole. Okay. So for the last piece of text, we are only working with the last line of text. Okay. We are trying to identify what is the width, height, and angle of rotation of the last piece of text. And from there, we get, okay, if this is the angle of the last piece of text, the assumption is that every other text will follow the same angle, and we just rotate it by a particular angle. Okay. 90 degrees, it's just to so basically the function is find non-zero images pixels, but since we are passing the binarized image where we are passing all of the black images, all the background is black, I had to do this minus 90. If we are passing the original image, we don't really have to do minus 90. Okay. No, binarize and this are unrelated. Okay. So again, don't try to understand this because this you will confuse yourself for the next things that are going to come. Okay. Please just understand the why, not the how. So I have created a function And this function does all the four things that we have selected as our pre-processing steps. And it is going to create a new folder called processed images. It will come over here. Okay. And for and if the output directory exists, then okay, otherwise create this directory. Then we basically do like a for loop. We list all of the items that are there in the training data set, all of the images that are there in the training data set, and we process each image in accordance with the function that we defined over here. Basically, confusion. What is the confusion? Anyway, we'll get to it, the confusion in a bit. So I have a folder that contains many images. I have written a for loop that for each image in that folder, process this image using this particular function. This is the entirety of the code for this. This much is understood? Yes, no? Okay. What's the function above? The function above is process one image. It takes the one raw input image and it does all of the four pre-processing steps that we defined earlier. Okay. And returns the processed image. Okay, so it will look something like this, the output. So I'll say processing image, the image name, converting image to grayscale, reduce noise in image, binarize the image, detected skew angle of 0.45 degrees. Yes, I'm calling all the functions like binarize dskew in this cell. So convert image to grayscale, reduce noise, binarize the image, correct image orientation or dskew the image. Okay. Corrected image orientation. Now I need to save the image. How do I save the image? Well, there is just how we had im show or im show. CV2 gives us really good image writing functions as well. One of which is im write or im write. Okay. The you just have to pass the output path. The output path is nothing but the output folder path and the image name, right? Output folder path, the new folder that we created called processed images. Okay. Then the image that has been processed, and yeah, that's pretty much it. We see that there are some images it worked on and some did not need any orientation correction. So let's do one thing. I'll just take this one. So is there anyone with a big orientation issue? So 2.91. So I'll just take this one and see if DSQ works. Let's just check if DSQ works. This is definitely a bit skewed, and we'll just do this. Yeah, it looks a bit skewed. Does it not look a bit skewed? Yes, no? Tiny bit, yeah. Tiny bit like this. Okay. Oh no, it ruined the image, in fact. It skewed it even more. That's not good. Imwrite is a function to uh, to write the image. Just how we write a file, we can write an image as well. Yeah, it skewed it in the wrong direction, it seems. So slightly better, it seems. The text is at least flat, no? Interesting. But better than before, right? So anyway, let's move ahead. So the angle is getting no, that's it's not the angle is it's not incorrect. I think there's some issue in orientation. What there must be something happening with orientation. Hmm. Let me just try this again. Anyway, let's move ahead. Not a open CV class. Okay, so I have processed about 20 images. It takes about 10 seconds, so 2 seconds each. So 2 seconds to process uh, annoyed. I hope so am I, Anjali, but I'll try to figure it out and try to give you guys a better answer. Okay. Okay. So if you look at it, 20 images will take about 9.5 seconds. So 9.5 divided by 20 is about zero point 0.5 seconds. So zero point 0.5 seconds to process one page. Now imagine if you have a PDF of 100 of 100 pages. How long will that take? Right? It will take a lot of time. Yes, no? 2 to 4 hours, not really, but if I do 0.5 into 100, it will be what, 50 seconds. So almost a minute just to pre-process the image. Okay, just to pre-process the document, 50 seconds. So I don't think that's acceptable. But what you can do in such a scenario is do something called as parallelization. Pre-processing, if I do page 1 first or page 28 first, does it matter? So can I do 20 pages if I like take a very big server? Can I do 20 pages at one single time? So parallelization is absolutely critical when you are working with, uh, when you're creating an IDP solution for a production-based project. Okay. So definitely remember this point. Okay. So let's talk about Tesseract. Do we also incorporate batch? Uh, Not really, because uh, instead of processing it into a batch mode, you control the batch. So this helps in controlling the resources overall. Okay. Okay. So let's talk about Tesseract. Tesseract is the oldest good OCR engine. It is the oldest good text extraction engine. There have been many giants that are standing on the shoulders of Tesseract. In fact, there are many paid products that have modified Tesseract and use it to for their own models. Okay, you can even fine tune Tesseract. Yes, Adobe, Google, Amazon. Literally, the Amazon has a product called Amazon Textract. Okay, uh, it's like they are not even trying to hide it. So the Amazon is using it, and they are getting so much money from it. But anyway, okay, okay, is so. Can we just pause for 2 minutes? Is there anybody who else who didn't understand? Hmm. Before Tesseract, though, I have not started. So many people understood. -1 means understood or did not understand. I don't know. Okay. Okay. So I'll again, please remember, it does not matter uh, if you try to, you know, understand this piece of code, or if you don't understand this piece of code, it's the same thing. Nobody is going to literally interview you on OpenCV. What is more relevant is why do we need to take this particular step? You should understand that. Okay. It is one of the few places in data science where I encourage people not to go into the details. Until and unless you want to become like a contributor to OpenCV, don't get into the depth of it. For computer vision, you will have to get into OpenCV. But again, understand that there are certain functions that you will use in OpenCV, but you don't need, for example, the Gaussian blur function. You don't, do you need to get into the maths of the Gaussian blur function? No. But do you need to understand that there is a function called Gaussian blur? Yes. Okay. Hmm. Okay. So, uh, Tesseract. Well, there are a lot of competitors for Tesseract, but what is most important is that it is free. It has existed the longest. It has been developed in development since way before even I was born. Okay. And it incorporated deep learning in around 2014. And Sir, how old are you? I am 34. Okay. It's not obsolete. It's frequently updated. Tesseract version 4 is absolutely amazing. And it has a support. It has support. What is that drink? It's coffee cold brew. Okay. But anyway, coming back. Please don't distract me. Yeah. So it has many languages support, over 100 plus languages. It is the only OCR engine I know other than Google Vision that has so much support for so many languages. It you can provide the form output in plain text, HTML, as a tab separated value, not a comma separated, because your data can have commas as well. Okay. And it does provides you, for each character it provides you a confidence score as well. And for you will have not just um, Python access, but you can also have command line access. So Tesseract is a command line term. You can literally execute Tesseract in shell in command line terminal. Okay. Now how to use Tesseract? So let me just zoom in. Yeah. So firstly, you will need to convert this into the image into a PIL object or a pillow object. Just a FYI, the full form of PIL, the full form of PIL is Pillow Image Library. So they were a bit creative with the name for no reason at all, it seems. But yeah, you will have to convert the image into a pillow object. Okay. Then there is a wrapper for Tesseract called PyTesseract. Okay. And then all you need to do is call the image to string function that is provided by PyTesseract on the pillow object. Is that understood? Okay. I'll repeat it again. So to run Tesseract on any image, you'll have to convert that image into a pillow object. How do you do that? Well, the image.open function does that for you. Okay, from the PIL or pillow library. Once you have a pillow object, you can literally pass it to the pytesseract.image to string function, and it will get you all of the text in plain string format. Okay, this is not txt file, this is not a html file, xml file, some nothing like that. This is plain string, and you can literally just print it or write it or whatever. Okay, understood? Where is the file? This is just sample code. I'll showcase what the file name is. What? Okay. So there is no file name or anything. This is sample code. This is not. This is like, you know, markdown. Yes, image.open file name makes the pillow object. Okay. So let's just install PyTesseract and Pillow. And as you can see, Google Colab already provides PyTesseract and Pillow. Uh, yeah. So, okay. Now, let's just try as an experiment on one of our images. The processed images are over here, if you remember. How can I get the path of any of these images? Well, I'll just click over here and I'll just click copy path and I can literally just paste it. Okay. Did I just choose the first one? Yeah, seems to be the case. So again, all I'm doing is the file name. Obviously, the file name has to contain the absolute file name, which contains the path and everything, right? Image.open image.open returns a pillow object, and then pytesseract image to string. Since I'm not storing it into a variable, it just prints it out to the console. Okay, understood? Only a pillow object can be converted to text. Yes. Okay. Now, since we know how to convert one image to text, Can we convert all of the images? What is pillow object? Good question. Uh, Pillow object is a special representation of an image that not only contains the information to render the image, but also the metadata around the image. Things like height, width, pixels, density, DPI, when was it created, by whom was it created, when was it last modified, all of those things. Right? So that is a pillow object. Okay. So can we directly give the path as a file name, or first we have to define is always what? Uh, I think you have to, you can do something like this as well. This is perfectly fine as well, and you can do. But you will have to do image.open no matter what. Okay? Okay. So as I was saying, yes, we need to run a loop. So good. If we are able to get the text from one image, we can run another loop, just how we did for pre-processing the images. We just, instead of the raw images, we just run it on the processed images folder, and then we just run the loop. And again, much of this is fairly similar. We just pass the image path name, input folder, right? Input folder path. The output folder path is something that we will be creating. So if it does not exist, make the directory. Otherwise, it's okay. This is what make dirs exist underscore okay equals true does. Okay. And then you can ignore this code. You can ignore this code. But yeah, we are just, wait, so we are just getting the, array yaar, we are just getting the input image path, okay, by joining the input folder path and the image name, right? Okay, okay. Then for, for the image, we just do pytesttract.image to string image.open image.open the path. This contains the complete path, the absolute complete path. Okay. Why am I saying the complete path? Well, we are adding the input folder path and the file name, image name over here. So to make it the absolute complete path. Okay. Okay. Then we generate the text from each image by using pytesttract dot image to string. Again, remember we have to pass image.open, and in this we can pass the image path. Then we just say what is the output path. The output path is nothing but again the folder name, and we just replace the extension from jpg to txt, and this will give us the output path, and we just write the text. Okay, this is not JSON. We are only using txt files right now, because this is not extracted text, extracted information. This is extracted text, if you remember. This is the extracted text, not the extracted information, which is in JSON format. Okay. So now we have done text extraction. What is going to be our next step? Just a stop. Why are we using with open file at last? Okay, so I'm writing the output text as a text file, and when I use if, I don't need to do f file dot open, file dot write, and file dot close. Instead, I'm just this with this with all the file dot open and close will happen on its own. This is considered to be a better way of coding, because this way, if you don't ever forget file dot close, and all of the files, these are stored in RAM, right? So if you open up like 20,000 files and you don't close them, your RAM will be exhausted. But with that has no chance of happening. Okay. Yes, we need to pass all of this to an LLM. Good. So we need to do something called as information extraction. Okay. Okay. So to do the information extraction, we'll do the same process that we did yesterday. We'll take the prompt, we'll ex and let's just go through the prompt. Let's just go through the prompt. Extract the information from the given image. The information to be extracted is company, date, address, and total. The image has been converted to grayscale, noise reduced, binarized, and deskewed using OpenCV. I don't know why I passed this. I thought that the this would help, but it's okay. I just passed this. Okay. Always give your response in the following format: company, company name, date, date, address, address, total, total. Also, the text has been extracted from the image using Tesseract. Use the extracted text as support. Remember, as support for extracting information. If you remember, I said that the image is the protagonist, the extracted text is just playing a supporting role. If you believe the extraction is incorrect somewhere, you may correct it yourself and provide corrected information. I am saying to the LLM, correct if the text extraction is incorrect. Respond with the extracted information only in the specified format. Here is the text. Okay. Okay. Everybody understood this prompt? Is there any doubt in this? I have a doubt. Can we use the unified framework for this prompt? Can we not? If it goes wrong, it goes wrong. You're not going to be able to build a system that's like 100% accurate. Okay. Can we use the unified framework for an effective prompt that we talked about yesterday to create this prompt? Will you guys try that? Yes, asking prompt to generate prompt. That is what we learned yesterday. Okay. So definitely try this out. Okay. And again, this is the similar code. So I'm not going to talk too much about it. We have to import, basically import GenAI from Google, from Google Colab. This is again just Colab only code. This is specifically to get all of the information from your Google secrets. Okay. Then we'll have to I'll explain why are we using this, but yeah, we'll have to import the pillow library again. Okay, remember our output is going to be JSON, so we are going to output the JSON. We'll have to import JSON library. Then we are just importing time to basically understand how much time does it take, right? No doubt over here. Okay, then what are we going to do? We are going to create the GenAI client. sim it's the same exact way we are going to create the GenAI client. It's the same exact way as we did yesterday. GenAI.client, the API underscore key, remember it's lower and it's mandatory. You cannot just do this, okay? You cannot just pass this, it will not work until and unless they have updated the versions or something. But yeah, you have to do API underscore key equals. If you're just passing the API key, then don't. But yeah, if you're doing that, then just pass the API key over here. Over here, we are using Colab secrets. So user data dot get Google API key. Okay. Where have you declared the API key? I have declared the API key over here, sir. There are many more keys, but you don't need to be aware of those right now. Okay. In Colab secrets. Are you going to create new one today? New one for today? No, I don't think there's any need. Now I have like 20 keys, so I don't even remember which one I used in this particular notebook. But anyway, so yeah. So uh, what do we need? Remember the processed images and the tesseract output or the extracted text. And what is the output folder path? Again, the same process. We are going to run a for loop for all of the images, and we are going to run the to save the output in a folder called JSON output. Okay, so I'll go back to the approach portion again. Where is it? Yeah. Remember, we have processed the image, we have extracted the text, and we are at this particular step. In this particular step, we are passing the processed image and the extracted text as support. Okay. 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 Again, if the if the folder does not exist, make it. Okay. And then get the image path. You load the image, and again we are using with over here and image.open. Okay, not much to talk about over here. You load the text path, and then again with using with you do f.read. Okay, file.read. Excellent. Then what do you do? Well, remember in the prompt, it said here is the text, and then next line, next line, next line. We need to add the text, the extracted text underneath it. Okay. So we will just do prompt plus text. Simple string concatenation. Not much to understand over here. Yeah. Okay. But how do we pass image? How do we pass image to Google Gemini? There's a reason. There's a reason I did this. Yes. Pillow object. Just how Tesseract takes pillow objects, Google Gemini also accepts pillow objects when you're working with it programmatically. Okay. So if you remember in yesterday's notebook, so I'll just showcase yesterday's notebook. Just give me a second. if you remember in yesterday's notebook, we passed the prompt as contents, right? Yes, no? Okay. Today also we are going to use contents only, but instead of a string, our contents is going to be an array, or sorry, a list. The first item being the image pillow object, okay? And the second item is a dictionary list. Yes, list. Sorry, I said array. Okay. So if you have two different kinds of input, the text prompt, which is the basically the instruction, right? It has to be passed as a list, as a dictionary, right? And you have to say that this is the text, and then you pass the prompt. I'll repeat myself again. The contents are passed as a list with the first element being the image and then the second element being a dictionary that explicitly states that this is a text and the text should contain the prompt. Okay, is that understood? Any doubt in this? Image is generated, no image is, we loaded the image over here. Okay, this is the processed image. We are passing the processed image. Please repeat once. Okay, we are passing, we need to pass something called as contents. It's really important to remember that this is plural, right? This contains an S at the end. Why? Because you can pass multiple things at once. Last evening, we were not passing multiple things, but still we called it contents, okay? Because the name is contents, right? But today we are passing multiple things, and these multiple things, they are passed as a list, okay? The first element is the image pillow object, which we loaded over here, okay? And the second element is a dictionary that contains the entire prompt, and you have to be explicit that this is the text that is being sent. Yes, contents can be changed. Okay. Rest of the entire code, yes, that is why we chose list. Rest of the entirety of the code remains pretty much the same. Again, if you remember yesterday, we said GenAI client dot models dot generate content, model equals something, and then contents equals something. This remains pretty much the same. We said GenAI client dot models dot generate content. Model over here, I'm taking Gemini 1.5 Flash, and contents equals something, right? This something is defined over here. Okay, is that understood? Okay, so is dictionary mandatory for text? Yes, it is mandatory. Or is it required to mention text to highlight that it's the text? No, no, it's a mandatory, Vivek. Can't we map everything like prompt an image into one and share it to Gemini? So that this is what we are doing. This is you cannot like combine image and text data, right? What will it even look like? I don't know. That's not something that's possible, right? Either you convert the image into textual data or you convert the text into image data, but then again we are doing the inverse of what we did. That is not possible, right? Okay. But the prompt is the string, then why the text is required? Is it? It's a keyword basically, Praram. What is the prompt we are giving here, sir? Okay. No, no need to apologize, Siddharth. Sorry if I was harsh. So this is the prompt that we gave. It's fairly simple. I wanted to keep it simple today. I didn't want the prompt to be the focus of the day. So extract the information, uh, use extracted text as support. If you believe the extraction is incorrect somewhere, you may correct it yourself. Okay. The format we have provided. We have provided what all pre-processing has happened. And yeah, okay. Can we pass multiple images at once? Then you will have to pass it as a list. Although I do not recommend it because then it will take a lot of time to respond. List within list, yes. Okay. So the rest of the code is pretty much the same. Again, we are getting the metadata. Again, we are getting the prompt token count, the thoughts token count, the candidate token count, and total token count. Okay. Then we are just writing the JSON, that is the extracted information, using the JSON library, json.dump. Okay. That's it. We have written a JSON file. Okay. Now, how many of you did not understand this? The only new thing that we have done in terms of can you just do like understood not understood instead of -1, because I don't understand -1 +1. Okay. Yes, you have to change the prompt when you're working with different data sets. The only new thing that we did today in terms of prompt engineering is just pass an image to the contents, right? Otherwise, this is pretty much the same as yesterday. Yes, no? Okay. And over here, I'm just printing out how much time it took. So let's just look at some examples. Remember, there are 626 images in the folder. Okay. So we are loading the image. Good. We are loading the extracted text. The file name for the extracted text and the image is same. So that's perfectly fine. The information from image and text, the input token count is this. The output thought token count is none. The output token count is this. The total token count is this. And the output got saved to this. So let's just look at this image, this output. Let's just try to open up the image first. What was the output file name? Uh, it's 9758, 975. There should be like a search button. 66. That's way, way down. I think 64, 655. What the hell? 9758. Yeah, this is the one. So it looks like this. JSON output 9758. The JSON output looks like this. So let's just look at the image. Uh, what is the name of the company? 99 speed mart, not not. So 99 speed mart 5 by 8. Okay, that's not correct. It's S slash B, I think. Okay. Then what is the address? Uh, what is this? Lot PT 33198 Batu 4 Jala. That's a long address. So Lot PT Batu 4, and this looks correct. Sinar and everything. Yeah, Sri Sinar. Yeah, I don't even know where that is. 13.60 is the total amount, apparently. And yeah, so it works decently, right? It's not going to get everything correct, but it works decently because obviously we can uh, do a much better job of prompt engineering. We can explain that what are the possible values in data, in the address, the name and date and things like that. Currency is not there, it's okay. uh, so any famous product built on IDP? Okay, so I'll show you this, Trishti. Mhm. It's not showing. Yeah, I'm not. So this is a blog that I wrote way back in 2021. You guys see this? And this was published in AWS. And this was the launch of a product that I created in my previous organization. And it was called Drishti Document AI. So yeah, so that is the answer to your question, Vivek. So it ruled many banks, I would say. We had just for this particular product, uh, we had like close to 58 customers. So this is, I was the owner of this entire product. I had like 20 people under me, of not just, I think 10 of them were data science, rest for UI, DevOps, MLOps, things like that. So this I have spent like half a decade on IDP. So yeah. So let's look at some other data. Okay. I was not trying to, praise my own self, but is Scam Scanner a similar application? 5 years is a long duration, but consider that we had close to 60 customers. So yeah, Cam Scanner a similar application? Uh, yes and no. It does much more than just being an IDP. Acha, in dedication to work. Yeah, yeah. I guess that may be true. Anyway, let's come back. So, you guys see something weird is happening over here. When I was processing the ninth image, some error came. You guys see what this error is? Can you guys see what the message is? So, this is not something that is within my control. Uh, Basically, no, token limit is not exhausted. It's just that too many people are calling the same API, same server, same model at the same time. And I'm using a very small model compared to Gemini 2.5 Flash. I'm using the oldest model that is still available. of Gemini. Okay. Yeah, server is busy. So 503 is server unavailable. Okay. And this is why people are not using free API. So it's okay if you get such output, but the disadvantage of such output is that you should not be then running your entire code in a for loop, because then you will have to maintain a log of how many, this is what I was doing, processing image 7 out of 626, 8 out of 626. So if I would see like that 30 images are done, then I would start the for loop from 31. But that was the plan. But I kept on seeing this issue again and again and again and again. So I said, let's just process 20 images. And even that failed, because processing images is very resource intensive. Okay, that's that's pretty much it for today's session. What's the assignment for today? So the assignment for today is that I want you guys to play around with this resume dataset. And there are two reasons why I want you to play around with this resume dataset. Uh, Basically, you will be able, you will know what how to, if you look at the dataset, right, there are multiple kinds of people who are creating resumes, right? And there is one complexity, that this is a PDF and you will have to convert it into image using Pillow or any other coding language, or any other library, right? And then you can proceed ahead with the same code, almost the same code. Obviously, if you want to do some sort of prompt engineering, you can use the prompt unified prompt framework. But yeah, this is, yeah, you can use the same code, but definitely you'll have to change the prompt. So I'll just tell you where you'll have to make changes. You'll have to definitely change this particular piece, obviously, right? This will no longer work. You'll have to change this, right? So yeah, that's pretty much it. Other than this, you'll have to add one piece of code that converts the PDF into an image. Okay. And to make it simple for you guys, if there is a PDF, you only need to process only one image, the first page of the PDF. You don't need to process all of the pages. And I want you to process at least 5 resumes, because I understand that, this sort of situation can happen with you as well, where the server unavailable issue comes into play. But I need you guys to process at least 5 resumes, no matter what. You will have to change the prompt, the the way how to download the data set, and you'll have to add PDF to image capabilities. Okay. Yes, you will have to add that at the starting. Okay. So please don't leave. I'll just re-review what we went through today. Okay, what we did went through. Okay, I'll give you guys just a very small recap. We talked about the 6 definitive stages of an intelligent document processing solution. Okay, uh, we talked about how and why we are sending both the processed image and the extracted text to the LLM engine. We looked at the data set. Sorry. We looked at the data set. Okay. Then we did 4 pre-processing techniques, where I will keep on repeating. It's important to learn the why in this particular case rather than the how. Okay. Okay. We learned that we only need to this do this binarization for tesseract only. Okay. Then, yeah, we did like a for loop to process the images. What else? Then we learned about tesseract, and we learned about its really powerful capabilities, and we learned how to send one image to tesseract in Python, and then we passed all of the images, the processed images, to tesseract, and it gave us some output. Then simply we created a simple prompt, and then we used the same exact method to call Google Gemini, other than the fact that we have added contents. Okay, the contents is a list with image and prompt. Okay, okay. What details we need to extract out of the resume? For that, you will have to go through this link. Okay, just how I think you can understand, right? Which what you will need to extract. If you even just extract like name, current organization, and skills, I'm okay with that as well. Okay, because ultimately at the end of the day, that is just simple prompt engineering, ex identifying what is to be extracted, right? And we have already learned that lesson. So that's it for today. Again, we'll talk about Drishti someday else. But yeah, I hope this was an informative session. And again, I would just like to remind you that we did not learn a lot of difficult things today. We learned a lot of things today, and you will need to revise it. You will need to practice it as soon as possible. Okay? Please remember this. Thank you. I hope you have all of your doubts resolved, and I'll just say good night. Okay. Thank you.